Hello everyone. Today we are going to discuss about speech emotion recognition in audios for autism persons. Our teammates are P. Sai Kumar, R. Ritwik Kumar, A. Manish Reddy. We did this project under the guidance of Miss Tamilmani ma'am. This is the agenda we are going to discuss in this document now. First, abstract. Speech emotion recognition system for the children affected with autism spectrum disorder. Children with autism spectrum disorder have difficulty in identifying the human emotions. The goal of this project is to develop a model that could be used by these children to better understand the emotions of people around them. The speech emotion recognition solution is created using machine learning techniques. RAVDES is used to train this model. The feature extraction of the pre-processing step using Librosa library, the MEL frequency, substral coefficients and the zero crossing rate are extracted and used as the acoustic features to train the SVM model. This includes the study of different types of emotions, features to identify those emotions and various classifiers to classify them properly. The objectives are aim of the project to develop a model to recognize emotion from speech using Librosa library and support vector machine with RAVDA datasets to train a model. The scope of the project. The scope of the project is to collect a dataset which consists of audio files and the features are extracted or given to SVM classifier to classify the emotions. Introduction. Speech emotion recognition is the act of trying to recognize human emotions and affective states from speech. Speech emotion recognition is one of the maximum hard responsibilities in speech sign evolution domain. Its far studies vicinity trouble which attempts to reduce the emotion from speech signals. Speech emotion processing and reputation machine became commonly composed of three parts, which have been speech sign acquisition, characteristic extraction, and emotion reputation. These are some of the literature reviews, are some of the journal papers we have verified. Now, design and methodologies. In design and methodologies, there are four modules. First module is collection of datasets. Second module is pre-processing. Third module is feature extraction, and fourth module is classification. Now we are going to discuss about the module 1. RAVDES datasets was used to train and test the speech emotion recognition model. It involves in speech recordings of in 8 different emotional states. Module 2, pre-processing. Pre-processing of the data is to input audio files to Librosa library and NumPy array. After inputting the datasets into the NumPy array, it finds the missing data and null audio files and they will be edited out. And it will split the datasets into training and testing. Pre-processing of data is required whether the data is suitable for machine learning model. Module 3, feature extraction. The first step in this code involves reading each file from the Librosa library and extracting the MEL frequency substral coefficients. The default frame length of Librosa is used for this work. The MFCCs of each frame are stored in NumPy array and the first 13 MFCCs are calculated. This process repeated for all the files and emotion labels mentioned in each file's name, and it is easily extracted and stored in the same NumPy array. Through this analysis provides different results for speech emotion classification model and shows the classification accuracies for different number of MFCCs for the RAVDES data. The zero crossing rate of an frame is the rate of signal and changes of the signal during the each frame. The ZCR is to extract for each frame and taken the average for all the frames. Module 4, classification. The SVM algorithm has a few hyperparameters that can be improved to get the optimal performance for a given dataset. The SVM hyperparameters can be tuned and tested with the model manually. It's the classification method and is applied for classify the emotions after the feature extraction. It is classified the 4 emotions: neutral, sad, happy and angry. These are the standards and policies. Now we are going to discuss about the implementation. This is the architecture diagram. This is the data flow diagram in which we are collecting the collection of Ravider datasets. After that, pre-process the data. Next step, feature extraction. Next, we are training and testing. After that, by using the SVM algorithm, we are going to do classification. By that, we will get the output. This is the sequence diagram. Evaluation metrics. Evaluation metrics consists of accuracy, confusion matrix, precision, recall and F1 score. Here accuracy means the accuracy is the most initiative performance measure, and it is simplify a ratio of correctly predicted observation to the total observations. In this that we have high accuracy, then our model is best. Accuracy is a great measure, but only when you have symmetric datasets where values of false positive and false negatives are almost same. Then we do look at other parameters to evaluate the performance of your model. Confusion matrix. The confusion matrix is a matrix used to determine the performance of the classification models for a given set of test data. It can only be determined if the true value for the test data are known, and that tells how good our classification model. And we can perform the various calculations for the model such as accuracy, precision, recall. Precision. Precision is the ratio of correctly predicted positive observations to the total predicted positive observation. High precision relates to the low false positive rate. Precisions are interpreted from the confusion matrix. Recall. Recall is the ratio of correctly predicted positive observations to the all observations in actual class. Recall also are interpreted from the confusion matrix. F1 score. F1 score is the weighted average of precision and recall. This score takes both false positives and false negatives into the account. This is the input and output of our project. This is the demo video we referred. Conclusion. Speech emotion recognition has a promising feature, and its accuracy depends upon the emotional speech database, combination of features extracted from those database for training the model, types of classification algorithms used to classify the emotions, inappropriate emotions, class such as happy, sad, anger, neutral. In this research, a speech emotion recognition system has been developed for the children affected with autism spectrum disorder.
Data is mounted on Google Drive. Now we are installing libraries. Librosa, Soundfile, NumPy, SKN, PyAudio. Librosa is for music and audio analysis. And now we are importing our libraries: Librosa, Soundfile, OS, Globe, Pickle, NumPy is NP. From sklearn model selection, we are importing train test spread from sklearn neural network, MLP classifier from sklearn matrix, importing accuracy score. Now we are defining extract feature function to extract MFCC chroma mel from sound file. This function has 4 parameters: file name, MFCC chroma mel, x comma sample rate. We are loading the file name, resample type Kaiser fast. If chroma is true, then we get short Fourier transform of x and store the result in empty numpy array. If MFCC is true, then we are finding out the mean and stored the result in extract function. If same for chroma and mel, and then return the result. Now we are defining the dictionary to hold numbers and emotions available on Ravedays and test dataset. The 8 emotions are neutral, calm, happy, sad, angry, fearful, disgust, surprise. So we are observing all these 8 emotions. Now we are loading the data and extract the features from each sound file. This is the path of our data set, and we are extracting features MFCC, Chroma, Mel. Then we are splitting the data set to training and testing, keeping 75% for training and 25% for testing. Now we are observing the shape of training and testing dataset. 3939 is for training shape, and 1313 is for testing test shape. Number of features extracted are 180. Now we are using MAP classifier. It's a internal neural network for classification, and it's also called feed forward artificial neural network. So here we have kept alpha 0.01, batch size 256, epsilon 1e-08, hidden layers 300, learning rate adaptive, and max iteration 500. Then we are fit and train the model. So we are activation is ReLU here and learning rate adaptive. Now we are predicting predict the accuracy of our model. So why predict? Model.predict x test. To calculate accuracy of our model, we have imported from sklearn this function accuracy score, and we are rounding the accuracy to 2 decimal places, and we got 83.32% accuracy. This is a classification report where we got 83% accuracy, and this is a F1 score we call precision, and these are confusion matrix. Thank you.